if you look at a poodle, okay, so a wolf to a poodle, that's the degradation of a genome, right? That's like, going from something that's got significant heterozygotic, DNA sites to something that has, more so homozygotic DNA sites. Like that poodle has lost so much information and so much allelic potential. I don't think you're going to take two poodles and artificially breed them back into a wolf, because that degradation and that sorting out process has already happened. So you get a dog degrading into a dog. But
okay, but also consider, right, that particular organisms, let's say for arguendo's sake, I don't know this, I'm not claiming it, but let's suppose, for instance, that dogs and wolves share the same genes, right?
Sure,
So,
yeah.
like,
I agree they do, right? I'm sure you can find those nuclear DNA differences, those mitochondrial DNA. I'm sure you see plenty of similarities in
my
the
point. And my point, though, is that, like, particularly the difference between dogs and wolves, their primary classification, like the main reason we create the distinction between dog and wolf, not only because of their evolutionary history, is because of their social behavior. Wolves are more of a pack species as opposed to dogs, which operate more or less independently. Plus, I mean, it is likely to be the case that because wolves are non-domesticated, that they require the use of certain genes to be expressed more often, whereas opposed to a dog does not require the same genes to be expressed at such a high level.
Okay, so and I understand what you're saying, and I understand the outcome and results of these changes. But like for creationists, so for myself, like I said at the beginning, heterozygosity, which just really means just millions of, say, differences in DNA sequences and obviously chromosome pairs, right? We've got 46 chromosomes, more than enough information packed and compressed in those chromosome pairs to provide the necessary variety. So I would say that heterozygosity was built into organisms, say from the beginning, right, by the creator. That means long periods, because you're talking a lot about 100,000 years, 100 million years. They're not really required for, say, the production of new species. And here's what's important, because if I start with heterozygous organisms, visible distinctiveness, immutable, it's in offspring, it's going to be apparent. Okay, so recombination, gene conversion, things like this, that's going to provide many new varieties of combinations of traits quickly, since these differences are already built in. So my point is, these changes, these traits you're seeing, if they're being emphasized by, say, the pre-existing information, I don't believe you're going to get a dog as small as a mouse, and I don't believe that you're going to get a non-dog into something that's a dog. And it kind of seems like you're admitting that there are limits. So I just want to see where that empirical evidence really is. Go ahead.
No, so I'm kind of curious as to what you view particularly as information, because from the standpoint of genetics, it comes down to DNA and how it's read by RNA and tRNAs that deliver amino acids, right? So, I mean, I'm not sure how familiar you are with genetics, but
I would say that, like, obviously a definition of information, it's not easy to come by. I would define it as more of like an encoded, symbolically represented message, but it's going to be conveying expected action and intended purpose. Like, for example, if we look at the English language, let me just make this easy through analogy, ask you a question and let you answer it. It's made up of 26 letters. Let's take an English book. Okay, it's made up of words, chapters, sentences, paragraphs. Those are made up of that specified information, 26 letters. How long is it going to take through, say, typographical errors and misspellings to turn that English book into something that's not an English book, say something German, Korean, because it's a different code, right? So how long would that take, and is it possible? Go ahead.
Sure, I don't know. Quite honestly, the answer is irrelevant because it's entirely disanalogous to the way genetics actually operates.
I would disagree that I think the fact that you say you don't know is probably analogous to the fact that a non-dog population is not going to become, because you can believe, obviously, through faith, that a dog today came from something that was non-dog. But if we see dogs producing more dogs and we admit there are limits, you're not going to get a dog as small as a mouse. At the end of the day, We're just discussing religions, because I would say, and no offense, that what you have here is a deeply held science fiction based religion, right? Because if you can't explain to me
exactly how that's religious at all, the entire claim of evolution, and no more no less, is that change in allele frequencies, which you agree with, over successive generations, which are heritable by their offspring.
Well, we can see that these traits are heritable. I understand, like fossils and bones, those are not inherited. So if we're looking at a genetic level, because I'm telling you that heterozygotic DNA, it is logical, coming from a creationist, because God's command was to be fruitful and multiply. So he's obviously not going to create clones. And since he could not have done that, it's obvious that he would create heterozygous DNA. So when you say that these traits are coming about through different environmental and selection pressures, that's expected, given our model of pre-existing heterozygotic DNA. Go ahead.
Well, great. Then you don't have an argument, because that's what evolution predicts.
But how are you?
That the change in allele frequencies over populations given successive generations causes speciation.
Yeah, so obviously anybody could, because I agree, evolution means a change in gene frequency, a change in gene pool, a change in allele frequency in populations over time, right? Not individuals are evolving, populations are evolving. So no one's disagreeing with that. But the question is, are there limits? And I believe there are. You're not going to get a dog as small as a mouse. And we know there's animals as small as a mouse, like a mouse. And you seem to agree. You're saying that dogs today came from something that was non-dogs, long ago and far away, and that's fine. You can have that belief, but it's my point and my contention that that's not empirical observational science, because we observe limits. Look at Lenski's experiment. How many generations of E. coli has he produced?
Well, before I answer that question,
more E. coli.
Well, before I answer that question, right, I'm curious as to what evolutionary biologist has tried to make the point that you will get a dog as small as a mouse. And I've listened to quite a few of them, and I don't think I've heard that one particularly. I mean, granted, maybe it's a Freudian slip, but I don't think I've heard that one.
Well, and I'll answer that too, but what do you think about the quote, and you can look it up because I don't believe it's a quote mine, by Dr. Michael Ruse. He's an atheist zoologist and philosopher, right? So what he said, and he's obviously has an evolutionary bias, and he's even admitting this. He's saying that evolution is a religion. This was true of evolution in the beginning, and it is true of evolution still today. And I could provide that source. Would you agree with Dr. Michael Ruse on that idea?
No, I wouldn't, because I would disagree in how he is characterizing a religion.
Well, because if we see dogs producing dogs, mice producing mice, elephants producing elephants, but you're saying that mice, dogs, and elephants are all related through common ancestry, and yet we see clear limits today in the present. How is that not a religion? Because that requires faith. And
okay, so the question of how is it not a religion is, like, if you're saying that because we can't see it, so let me say it this way, right? If the strict reason you reject it is because you can't see it for yourself, and that's grounds to reject it, that's an argument from ignorance. But the better answer that we have, right? So the better answer that we have is by going back to the fossil record, is by going back to the history of organisms that have existed.
Okay, and I'll let you continue, but I just want to say, we find bones in the dirt. There is no fossil record. We find bones. It doesn't come with a label on it. It doesn't come with an identification card that says, "Hey, this evolved into this. This is the ancestor of this." And why would we expect a bone found in the dirt to be able to do something that an animal today can't, which is add new, novel, and meaningful information to the genome? Because my point is, empirically and observationally, we see limits. So that's why I'm saying everything you're telling me is contrary and contradictory to presently known data. Go ahead.